Welcome to aminacademy.com. In vectors, let us discuss about properties of definite integrals. Here property 3 will do. Integral a to b f of x dx equal integral a to c. We are introducing new limits here, c f of x dx plus integral c to b f of x dx, where a is lesser to c and lesser to b. Means we are introducing new limits of c in both integrals. Now let us prove it. Let f of x dx equal f of x. Then we can see LHS integral a to b f of x equal f of x with limits a to b, which is equal f of b minus f of a. Now RHS equal integral a to c f of x dx equal f of x plus integral c to b f of x dx equal f of x a to c plus f of x c to b, which is equal f of c minus f of a plus f of b minus f of c. Here f of c and f of c cut, we'll get f of b minus f of a. Therefore LHS equal RHS, hence proved. Therefore you can write the result one more time. Integral a to b f of x dx equal integral a to c f of x plus integral c to b f of x dx. Now we'll illustrate this property by figure. Like here is xy plane. Here suppose a curve AB. We have to find area under this curve. This point C, this D. Here take one more point in between A to B in the curve. Let it be E, and this one F. Here area under the curve of AB is equal to integral A to B f of x dx equal integral A to C f of x dx plus integral C to B f of x dx, which is equal area of ACFE plus area of EFDF DB, which is equal area of ACDB. In general, we can say A, the limit A is lesser to C1, lesser to C2, means in between you are taking limits of C1, C2, C3 like that up to Cn, which is lesser than B. Therefore, we can say in general form integral of A to B f of x dx equal, we write A to C1 f of x dx plus C1 to C2 f of x dx plus C2 to C3 f of x dx. It continues up to plus Cn to B f of x. So we have done. Please subscribe our YouTube channel.